Hello, so this is the practical section of our tutorial. So this is the website, the cargo website, where I expect you to download the data from. This is the front page, so I will enjoin you to click on the data page. Then you can scroll down and click on this download all to download the data set. And once you have downloaded it, you can extract it so that your Jupyter Notebook script will be able to have access. So if you want to learn more about the data, so you can just read through this. You can see it's got train.csv, which comprises of store, the store number, depth for the department number, date for the week, weekly sales, say for the given department in the given store. It's holiday, whether the week is a special holiday week. So and the like. All right. So now let's go to the Jupyter notebook. As I mentioned, we are going to be using the Walmart recruiting store save forecasting data, and we are going to import a number of modules, the necessary modules. So as we proceed with the course, we may import additional one. So the first one on the list is import OS. It allows us to perform operating system related tasks. For example, if you are using Windows, any version of Windows, and we want to be able to check the directory, I mean the folder, you can use OS. I will show you an example as we progress. Import 6, checking the current version of Python and can perform other tasks as well. Pandas for loading the data set and also for managing the data in case you want to limit. And this is one module that we'll be using more often in the course of this tutorial or course. NumPy for creating arrays and also doing mathematical calculation like conversion. You want to do log transformation of your data is quite useful. The matplotlib and the cbones are basically for creating charts. And they have added percentage matplot inline. This is to allow um, Python to display the chart within Jupyter Notebook. So if you are not too much familiar with Jupyter Notebook, there are tutorials. I have a tutorial, just Google my name on YouTube. Then you'll be able to find where I just went through the basic things you need to know or learn on how to use Jupyter Notebook. So one interesting thing we'll be doing is to click this play for you to be able to run your code. The way it is now, if you don't click on play or control enter, it will not run it. But so just to take you through the Jupyter Notebook quickly, but just like I said, if you want to learn more, you have a tutorial on that. And also there are tons of tutorial on the internet for you to learn. The first menu item on the menu is file. It allows you to create additional notebook. So if you don't have a notebook open already, you can just say new notebook. So we are using Python 3. So I've already created this. So this file will be shared with you later. So don't worry if you just try as much as possible to follow my teaching as I progress. So edit is for copying cells, splitting cells, moving cells up. Then view is to toggle the header. If you want to insert additional cell, this is will make it possible. This allows you to run the cell, run all above as the name entails. This allows you to interrupt the kernel. So I'm going to restart my kernel so that I can run everything from the beginning. And this is what I'm going to do. I'm just going to say restart. So you will see the impact of the uh, restart shortly. Okay. All right, I've already restarted it. So, and I want it to clear the output as well so that I can. So, one thing you will notice is that there used to be one in this particular input. Now, there's none as well. There's none as of now. So, here is the cell where we'll be writing our code. And the cell in Jupyter Notebook performs different functions. It can act as a code, it can act as a markdown, raw MB heading. The one we'll be using most is code and markdown. Once it is a markdown, that means you intend to write a comment or you want to make it a header. For example, if I double click on this, so you can see is in markdown format, and I've turned into a header by writing this hash sign. The same thing with this one. So that's one interesting thing about Jupyter Notebook. You can write as many comments as you like. So let's start with this first one, importing the module. Okay, so you will notice an asterisk here, an asterisk. So it's telling you each time you see the asterisk here, it's just telling you to wait, just like the hourly glass of Windows that tells you to wait. Okay, now let's go to the next item, working with directory. Actually is a good practice for you to set your directory. So when I mentioned directory in the course of this training, what I'm actually referring to is a folder for those of you that use Windows a lot. And for Linux people, directory is something that you should be conversant with now. So the first thing is to set your directory where you're going to put all your data file, where you're going to put maybe create additional folder to hold your model, for the sake of keeping your work organized. So I'm going to change. I've already created a folder titled Warmer Sources Forecasting. That's where I'm going to be putting my files. As I told you, OS the module allow you to interact with your Windows, so you can even use it to create a folder or directory. All right, I'm going to run this. Okay, it has run, so it has changed the my directory to this one. So if you want to confirm whether it has changed the directory or not, so you can just do something like this: OS get, and click on this one here. It will tell me the. Okay, so you can see that's my current directory. So current folder, current directory. Okay, so now I want to list the item by using os.list directory. You can list the directory. You don't necessarily have to cram all the code. In Jupyter Notebook, once you type the name of the module and you press tab, it gives you an info of the kind of additional command you can write. You can see under OS, I can do access abort ABC CHDR, which is change directory and the like. Okay, so you don't have to cram all the code with the head. You can, okay. All right, so I want to list the items in this directory. Okay, so I have 1, 2, 3, 4, 4 items. They are basically folder because they don't have any extension. All right, so now I want to list a particular one, the folder which is 01 data, where I've downloaded and I've put my data. All right, so you can see the items that I have there. These ones are not folder because they've got extension .csv. They are basically .csv file. So if you have downloaded your data and it is a zip format, I will implore you to extract it so that we can be on the same page. One interesting thing with the packages that we are using is that they can also interact with zip file, but we are not going to do that as far as this course is concerned. All right. Okay. All right. I don't need additional file for that. So I'm going to the section of loading the Wama Save Forecast data set. So this is the stage I want to load. So I'm going to name the name of my data set name, the data frame train underscore data set. And I'm going to ask it to read the folder and the data set, the data file train.csv. So one thing you will notice here is that I've shortened the name of the folder. The reason why I'm able to do this is because, just like I mentioned, I created a directory. I've created a folder, set a folder where have told Python to get all my data file from. For example, look at this one up here. I'm going to create another cell and I'm going to do exactly what I did with this using the absolute directory. All right. So look at it. I'm going to say this is the version, my version 2. Okay, data directory. All right, instead of using this entire code, I'm going to just shorten it to something like this. Okay. Yeah, you can see the result on your screen. I was still able to achieve the same thing. Basically because I set my default, my working directory. Okay. And also, if you look at the backslash, maybe you have been using Jupyter Notebook and your backslash, instead of you have been using forward slash, and it work. It will work, basically because the default way the program works in Python is like that. The reason why I'm able to use this because I've added this R dot because I use Windows and I use Linux as well. But because I copied this directly from Windows, so that's why I have it this way. So in case you run and you run your folder and you run into problem, so just note the possible reason for that. Okay. So let's go back to the section where we load the Walmart sales forecast data set. So this is where we did that. So just say if we run it like this, you can see it's saying 7. That means it has finished running. And you saw an asterisk here. As I explained the other time, it indicates that the program is still loaded. So because my data file is not that big, so I was able to load it quite fast. All right, so I'm going to the section now of viewing the data and its properties. Now let's start with the length. How big is this data set? Okay, it has 421,570 records. So when I talk about records, I'm talking about rows. So let's see more information about this data set. You can just do train dot. Let's look at the shape. All right. So it's giving us the same information, but we have additional information. It's giving us the number of records. Note that number of records and the and you have the number of features as well. So for those of you that are coming, have the background coming from statistical background, when I talk about features, I'm talking about the variables, I'm talking about the columns, I'm talking about the fields. So I can, in the course of this training, I can be using those words interchangeably. So when I say variable, except I'm creating it in Python, I specifically this is Python. I may be referring to the features, but we try as much as possible to use the word features. Okay, now we're still viewing the data. So we have looked at the number of records, we are looking at the shape that gives us information on the number of records and also the number of features. Now let's look at those characteristics, the attributes closely. Okay, all right, here we go. You can see the our data set contains 5 columns, and in addition to that, it has store, depth, which is department, date, weekly stay is holiday, and some of them are in integer. Int stands for integer. O stands for object. Object is usually numeric, alphabet characters. So yeah, you must know that. His holiday is blue. Is bull is indicate is a yes or no, false or true kind of data set. It's a binary data set. When I say binary, I mean binary feature rather. Something that has got two values, yes or no, true or false, and the like. So you can see it here. It's already false or true. Okay. And we have the store data, we have the department data, we have the date. So the date, as you can see, in the storage format, it was a data format, it was stored as an object. So as you work with date, you may need to convert it to date to be so that it can be in date proper. Yeah. So we have information on the weekly sales and the like. The name of the store is there. The department is here. It says recorded on the weekly basis. Okay. Now creating additional features from the existing data set. So one practice that we data scientists do is to create additional data set from the existing one. Okay, and we do a lot of data management and manipulation. So in this course now, the first step is to convert date feature to date formats. I've explained that to you. So now by running this code, train data set. So this is the date value. So I'm overwriting it. So if I don't want to overwrite it, I have to change the name maybe to date X or date in date format. So this command pd to underscore datetime, we convert this. Note that pd stands for pandas. Let me scroll up quickly. You can see I've abbreviated pandas as PD, numpy. So when you see me calling PD, MPy, PLT, so I'm just using the aliases. Okay. Yeah, because I cannot be, for the sake of space, I cannot be writing PDE pandas every now and then. Okay. So the question is that why am I using PD? So it's like a standard kind of abbreviation that people use for pandas. But if you want to decide that I don't want to use PD, I want to use CD, so it's left to you. But to be on the same page, it's advisable you use pandas. Okay. Now, in addition to adjusting, converting our datetime from object, from character, from string to date, we need to extract year and month. Okay. Okay. So this is the command. You can see what I'm basically doing here is to create a column title year, a feature title year, and a train data, if another feature title month. I'm extracting the year and month from date, and it's made possible because I've already converted that feature or column to date to date time. All right, let's see the action. All right. Okay, so you can see the results, the impact of what I did previously. You will have the dates, and now we have the from this date, I've extracted the year. The year in this context is 2010. The month is 2. Okay. All right. So now let's see. Let's check the data from the number of years. I want to see how many number of years have got here. Okay. I only have 2011, 2010, and 2012. So the data ranges from 2010 to uh, to 2012 basically, and you can see the number of records per uh, per year. Okay. Remember the essence of this practical section is to be able to explain, to plot all those graphs that I plot in the course of presenting the peculiarity. So all that I'm doing now is just to be able to achieve that. And the first thing you have to do is to create the year, because I told you that we see all these peculiarities better by aggregating our data. So, so that's what we are trying to do here. All right, so let's go back to our data, the train data set, just to get the number of records. We have 421570. Okay, all right, so now train monthly sales. What I'm basically doing here is to collapse the data to be in from to progress from weekly sales to monthly sales. And to be able to achieve this, I need to engage group by store department year and month. So, and I need to be able to aggregate some the data. So this is quite a long code. You can scroll to the left to see how it works. So now I've run this code now. So now let's see what has transpired. So because I've aggregated it, you see the number of records has gone down from 400 plus to just 100,000 plus. And let's see an example. Okay, you can see now, unlike the original data, let's quickly scroll up. The original data is on a weekly basis. You can see the weekly sales here, but something has changed here. So we don't have weekly, and we now have monthly sales. So you may be wondering, how did I come about this? Okay, it's clear how we computed the year and the month. The one that may not be clear to you may be the monthly sales. As I explained earlier on, so the data has been aggregated it's now at the month level. So now what I did was here was to change the name of the column from weekly month to monthly sales. So to reflect what I have here. And one interesting thing you will notice that on a monthly basis is now 131,000, unlike the one you have on a weekly basis, which is 24,000. So that makes sense. Yeah. Okay. Now, what we want to do next is just to filter the data. We cannot plot using all the stores, using all the departments. There are quite many. We're still going to delve into them later. So let's see number of categories now. Okay. So just like I said, you see we have 45 stores and 81 departments. That's a lot. So now, in order for you to have a proper understanding. So what I'm doing is to reduce the records to a minimal level that you can be able to understand. But that doesn't restrict you from doing it for all the stores or the department. There's no restriction. If you want to do that, you can do that. Okay. All right. So we are restricting the data to store number one only. Okay. All right. So just for this store number one, we have 241, 2,412 records rows. Okay, so I've stored, you can see the data frame is now stored one only. It's always a good idea to always keep your original data in case you run into problem and you want to revert back to it. So I've created a data frame that holds all the stores in that holds all the records of store one. So I want to further restrict the data just to department one only. And I'll be able to do that by running this code. You can see my filter command, and also you can see I use the same thing here. All right. So I'm splitting it so that you'll be able to understand it. It doesn't mean that I cannot combine all this code into one. Yeah. So, but because I wanted to have to get it quite all right. So now look at what I've done now. I've restricted the data to store one and department one only. Let's just view the top records. So I'm just viewing the top four records. You can see everything here is store number 1. You can see, and department number 1. Okay, you may be saying, no, I want to see all the 33 of them. I want to see all the 33 of them. If you want to see, just come here and just type 33. Okay, so as you scroll down, you see, but the maximum number here is 32. It doesn't mean it's not 33. One thing about Python is that it starts counting from 0. You can see 0, 1. So this is basically 33 records. Okay, but we normally view the top one because we just want to have an idea of the data. So we have only department 1. You may be saying, do I still have other record? No. For example, let me change this one to 50. So it will not go more than 33 because I only have 33 record. Okay. Let me just collapse this back to 4. Yeah, so that our Jupyter notebook will look tidy. All right. Okay. So I want to count how many records you have in year 1. Okay. So I only have in the years rather. Okay, in 2010 I already have 11. In 2011 I have 12. In 2012 I've got 10. Okay, so what is the implication of this? So it's telling us that uh, some of the years they don't have the data for all the months because basically we have 12 months in a year. But it's fine, we'll still be able to achieve. Okay. Um, Now I want to exclude the 2012 data. The reason being that it doesn't show the pattern, the peculiarity that I would like to show you people. So it's advisable we exclude that. Okay. So now it's time for us to plot the sales chart. So to be able to plot, you need to install uh, the Seaborn, the version I have on my screen. I tried the latest version, it didn't work. It didn't do the plotting. So that's why I'm using 09.0. Okay, so you can just run this line of code, you can type it in. Remember, for you to be able to run system level kind of command, you need to add this exclamation mark. So what you need to write using the command prompt, you'll be able to run it here. Okay. All right, I've already run it, so I don't need to rerun it. Okay, so this is Cborn. Okay, I'm just re-importing it for the sake of emphasis so that we know that this is my Cborn. So because I've already imported it, there's no need for me to import it, but it will not complain. So yeah, so let's just have it like that way. So this is X. X stand for X axis. That's the the horizontal axis. Y is the vertical one, and this is taking putting into consideration my year. So I don't necessarily need this one. Okay, so I'm plotting the 2010 and 2011. So this is actually a data frame that I've named it Note 2012. You can use whatever name you want to use as you do your own thing. All right. So let me set the grid. Okay, I didn't set that earlier on. Okay, so I've done my plotting. So you can see the results. Mhm. So just I've explained. Uh, so this is showing the trend. You can see an upward trend, downward trend, going up and down, going up and down. And one thing you can also notice here is this is latitude. You can see this period. This is April. This is around Easter period, the Christian period of festivity. And you can see December here. And actually, the the other plot is shown in this faint kind of color. So you can see it's actually on top of one another. If you can trace it, you can see this is data coming from different years. But one interesting thing you will notice is that They are almost the same. So that means with this data, you can easily predict 2011. Look at the 2010 here, almost the same peak. Look at it here, almost the same peak, almost the same low. You can see this one is all exactly the same here. All right. So that's the beauty of time series data. So you can be able to project, you can be able to forecast, you can be able to predict the future from the past. So that is the okay. All right. So here is another. You just plotting it the same way. All right. So using all the data. So now this is just to explain the reason why I exclude the 2012 here. I'm using the store one, all the data without excluding the 2012 data. So I don't know what is 2009. Yeah, so I may need to go and check my data. So you too, you can check. Okay, you can see this is showing the 2012. The 2012 is not reflective of the other, so the pattern is quite different. Oh, a number of reasons maybe we may have a number of reasons for that. One may be the quality of data. Another one may be that okay, maybe there was something wrong with this particular uh, company. So this store handles department. Maybe they've stopped the product. Maybe they have given it a different name. Maybe it's a TV series, and maybe another one is just like using all this popular brand, and they've come with a different series, and people are no longer buying that one and stay in store. So you may have a number of reasons for that. Okay. All right. So the essence is just for you to be able to have a kind of understanding. So I think we've come to the end of the practical section for video one. So now from here, we need to proceed to video two. And your assignment is to look at the other store, like store two, and look at the maybe the department one. Also, you can still stay with store one and look at the other department and see if you can see some kind of trend, and also the cyclicity that I talk about. So you can you can just visualize. So it will be an interesting task to do. All right, I will see you in video two. Thank you very much for being part of this course. See you next time.